Good day everyone! For today's lesson, we are going to study about trigonometric identities. This is one of the most exciting topics in trigonometry. This topic is also important in calculus, the subject that you are going to take in the next semester. I hope that through this video lesson presentation, you will appreciate the beauty of simplifying and proving trigonometric identities. The learning objectives of today's lesson are the following. Number 1, simplify trigonometric expressions. And number 2, prove trigonometric identities. I am very sure that after this lesson video presentation, we are going to achieve these learning objectives. Okay, before we start studying the different trigonometric identities, let us first define what is an identity. An identity is an equation which is true for all values of the variable. So this is an example of an identity. 2x minus 6 is equal to 2 times quantity x minus 3. Why is it an identity? Okay, let us see. If we use x equals 2 and we substitute this to the equation, let us see if this is an identity. So 2 times 2 minus 6 equals 2 times 2 minus 3. 2 times 2 is equal to 4 minus 6 is equal to 2. Then 2 minus 3 is negative 1. 4 minus 6 is negative 2. And 2 times negative 1 is also negative 2. As you can see, the left and right sides of the equation are the same. That is why it is called an identity. In this lesson, we are going to talk about the fundamental identities. These fundamental identities are the most important identities among the different trigonometric identities. First is the reciprocal identities. There are three reciprocal identities. First one, sine theta is equal to 1 over cosecant theta. It is the same as cosecant theta is equal to 1 over sine theta, because sine and cosecant are reciprocals. Second, cosine theta is equal to 1 over secant theta, or secant theta is equal to 1 over cosine theta. And the third one is tangent theta equals 1 over cotangent theta, or cotangent theta is equal to tangent or equal to 1 over tangent theta. The next set of identities are the quotient identities, which are number 4, tangent theta, which is equal to sine theta divided by cosine theta, and cotangent theta, which is equal to cosine theta all over sine theta. And the last set of fundamental identities are the Pythagorean identities, which are number 6, sine squared theta plus cosine squared theta equals 1. And number 7, 1 plus tangent squared theta equals secant squared theta. And number 8, cotangent squared theta plus 1 equals cosecant squared theta. We are going to use these 8 fundamental identities in simplifying and proving other trigonometric identities. Let us have first example. Simplify the following trigonometric expression using the fundamental identities. So secant theta minus sine theta times tangent theta. How we are going to simplify this? We are going to use the identities provided at the right side. So what is the equivalent of secant theta? We can use the second identity. Cosine theta equals 1 over secant theta, because cosine and secant are reciprocals. Therefore, secant is equal to 1 over cosine theta. Okay, so 1 over cosine theta. Copy yung sine. So, sine theta times, what is the equivalent of tangent theta? Using the fourth identity, tangent theta equals sine theta over cosine theta. So we can now copy 1 over cosine theta, then multiply sine theta times sine theta, sine squared theta, all over cosine theta. So we can combine the two terms because they have the same denominator. So we have 1 minus sine squared theta all over the common denominator cosine theta. And what is the equivalent of 1 minus sine squared theta? So we can use the sixth fundamental identity because it states that sine squared theta plus cosine squared theta equals 1. And we solve for cosine squared theta is equal to 1 transpose sine squared theta. It becomes minus. So minus sine squared theta. So therefore, the value of 1 minus sine squared theta is cosine squared theta all over cosine theta. And what is cosine squared divided by cosine theta? So subtract the exponent. So 2 minus 1, we have cosine theta. So therefore, the simplified form of the given trigonometric expression is cosine theta. Second example, simplify secant squared theta minus tangent squared theta all over sine theta. It looks complicated, but this is a very easy trigonometric expression because as you can see, secant squared theta can be simplified as 1 plus tangent squared theta, right? Using the seventh fundamental identity. So we can use instead secant squared theta, we have 1 plus tangent squared theta minus tangent squared theta all over sine theta. So we can now remove the parentheses. We have 1 plus tangent squared theta minus tangent squared theta all over sine theta. And tangent squared minus tangent squared is 0. So we have 1 all over sine theta. And what is the equivalent of 1 over sine theta? The reciprocal of sine. And the reciprocal of sine is cosecant theta. So therefore, the simplified form of the given trigonometric expression is cosecant theta. Okay, what if we are going to prove that the given equation is an identity? What we are going to do? There are three common steps. First, manipulate the left side to make it similar to the right side. Secondly, manipulate the right side to make it similar to the left side, or manipulate both sides for them to make the same or similar. Okay, but the common step that we are going to do is simplify the more complicated one. If one of the sides of the equation contains only sine or cosine, use the other side to manipulate and to make it the same with the other side. Okay, let us have example. Prove that sine theta, cotangent theta, secant theta equals 1. So, the more complicated one is the left side of the equation. So, we have to simplify this to make it the same as 1. So, we can now copy sine theta. And what is the equivalent of cotangent theta? Using the fifth identity, cotangent theta equals cosine theta divided by sine theta times. And what is the equivalent of secant theta? Using the second identity, they are reciprocals. Secant and cosine are reciprocals. So secant is equal to 1 over cosine theta. Okay, is it equal to 1? Let us see. So sine theta divided by sine theta. We can now cancel this. Cancel. And cosine theta divide cosine theta. So cancel. So therefore, 1 is equal to 1. So we can say that the given equation is an identity. Example, cosine theta plus cotangent theta times sine theta divided by cotangent theta equals to sine theta. The more complicated one is the left side. So we will manipulate the left side to make it equal or the same to the right side. Since there is one denominator or single term denominator, we can decompose the given fraction into two similar fractions, which is cosine theta all over cotangent theta plus cotangent theta sine theta all over cotangent theta. Is it equal to sine theta to 2 sine theta? Okay, let us see. So we can now cancel cotangent theta, and we know that cotangent theta in the denominator is the same as using the fifth identity, cosine theta divided by sine theta plus sine theta. Okay, so 2 sine theta. Okay, so simplify first cosine divided by cosine over sine theta. So we will get the reciprocal of the given denominator and we will proceed to multiplication. So times the reciprocal of cosine over sine is sine divided by cosine plus sine theta. Okay, so we can now cancel cosine, right? Okay, cancel cosine and we have sine theta plus sine theta. Okay, can we add sine theta and another sine theta? Yes, because they are similar terms. So we have one coefficient of 1 to both sine. So sine plus sine is equal to 2 sine theta, which is equal to 2 sine theta. So therefore, we can say that the given equation is an identity. Let us have the last example. Quantity secant theta minus tangent theta squared equals 1 minus sine theta all over 1 plus sine theta. Okay, as I have said earlier, simplify the side of the equation that does not contain sine or cosine. Okay, or the more complicated one. And we can see that the left side is the more complicated. So we will simplify the left side to make it the same with the right side. Okay, so what is secant theta minus tangent theta quantity squared? So we can use FOIL method, right? Okay, square the first. Second times second is secant squared theta. Then the operation, so secant theta times negative tangent theta is negative secant theta times tangent theta. Then twice it or multiplied by 2. So we have minus 2 secant theta times tangent theta. And then negative tangent theta times negative tangent theta equals positive tangent squared theta. Okay, we will prove that this is the same as 1 minus sine over 1 plus sine. We know that secant squared theta is equivalent to what? 1 over cosine squared theta. We'll just put squared. It is the same with the previous example. So secant equals 1 over cosine. Therefore, secant squared equals 1 over cosine squared minus 2. Then secant equals 1 over cosine theta. Then tangent equals sine over cosine theta. Okay. Then we have tangent squared theta is equal to sine squared over cosine squared, right? Using the third fundamental identity. So let us simplify. Copy 1 over cosine squared theta minus 2 times 1 is 2 times sine is 2 sine theta all over cosine times cosine is cosine squared theta plus sine squared theta all over cosine squared theta. Can we add the three fractions? Yes, because they have the same denominator. Similar fraction sila. So we can now copy cosine squared theta. Then 1 minus 2 sine theta plus sine squared theta. What we're going to do to the numerator? So we have to factor. This is a perfect square trinomial, and the factor of this is 1 minus sine theta quantity squared all over cosine squared theta. And what's the value of cosine squared theta? Using the sixth fundamental identity, cosine squared, transpose natin yung sine squared. So it is 1 minus sine squared theta. Right? Okay. So we know that 1 minus sine theta squared is the same as 1 minus sine theta times 1 minus sine theta. Okay. And the factors of 1 minus sine squared are 1 plus sine theta times 1 minus sine theta, right? Okay, sum and difference. Okay, we can now cancel 1 minus sine theta and another 1 minus sine theta. And this is equal to 1 minus sine theta all over 1 plus sine theta. So, we prove that the given equation is an identity.